Hi everyone, I'm Emma. Welcome back. Today I want to share a simple but very exciting idea. Building a DIY robot that can actually define its own behavior using AI. This project is perfect if you want to combine hardware and artificial intelligence in one hands-on experience. It shows how a simple prototype can move from being a fixed static machine into a small learning system that improves over time. Let's break it down step by step. Most beginner robots follow fixed instructions. For example, if there is an obstacle, turn right. If the path is clear, move forward. That works, but it's predictable. The robot never changes. Now imagine something slightly smarter. Imagine a robot that can sense its environment, make a decision, act on it, and then adjust its behavior based on what happened. Now that is the core of this project. We focus on a simple learning loop. Sense, decide, and act, and then repeat. This small cycle is the foundation of almost every intelligence system. The hardware doesn't need to be complicated. You can start with a small robot chassis with two DC motors and distance sensors like ultrasonic sensors, a small camera modules, a controller board like an ESP32 or a Raspberry Pi. If you want something low power and affordable, ESP32 is a great choice. But if you want more computing power for vision or AI models, a Raspberry Pi is better. You connect the motors using GPIO pins and control speed with PWM signals. The distance sensors connect through digital pins. The camera connects depending on your board type. That's it. Simple hardware. Now comes the interesting part. Instead of only writing fixed rules, we add a simple AI model. It doesn't need to be complex. Even basic object detection or simple decision logic is enough. For example, the camera detects objects. The distance sensor measures how far obstacles are. And the robot decides where to turn, slow down, or stop. At first, the robot might only follow a basic path, but then we allow some parameters to change during runtime. For example, turning angle, speed, and distance threshold for obstacle detection. If the robot hits obstacles too often, it adjusts. If it turns too sharply, it softens the turn. This is how it starts defining its own behavior. If you want to make the project more advanced, you can use MQTT for communication. With MQTT, the robot can send sensor data to a computer or a cloud system. You can monitor performance in real time. You can even update parameters remotely. This makes the robot part of the IoT system. It's no longer just a moving toy. It becomes a connected device. Now a practical example. Let's say your robot starts by following a simple line or path. At the beginning, it moves, for example, forward. It stops when it detects an obstacle. It turns randomly left or right, but after collecting data for some time, it notices patterns. Maybe turning right works better in your environment, or maybe slowing before obstacles reduces collisions. So it adjusts. how it avoids obstacles more smoothly. It moves more confidently. It behaves differently than even it first started. That's the transformation from static logic to adaptive behavior. This project teaches you several important concepts: embedded systems, motor control with PWM, and sensor integration, basic AI logic, real-time decision making, and IoT communication, system feedback loops, and most importantly, it teaches you how intelligence is built step by step. You don't start with a complex neural network. You start with a simple loop: sense, decide, and act. Do you remember? Improve. That's how real robotic systems grow in complexity. Here are a few important tips. First, keep your learning cycle small. Don't try to build a fully autonomous robot on day one. Second, test each part separately. Means test sensors alone, test motors alone, and then integrate them everything. Third, monitor data. If you can log sensor values and decisions, you will understand behavior much better. Fourth, balance hardware and software. Sometimes problems are mechanical, not logical. And finally, keep it modular. If you design your robot in modules, you can upgrade parts later without rebuilding everything. Once your robot works, you can expand it. Yes, you can add, for example, better object recognition, mapping and navigation, cloud-based learning, multiple robots communicating together. This small DIY project can become the foundation for advanced robotics or IoT systems. And that's the beauty of it. It starts simple, but it grows with your ideas. This kind of project is not only educational, it's practical. It helps you understand how intelligent systems are built in the real world. Okay, we're done. And if you have any electronics project in mind, whether it's robotics, IoT, PCB design, or embedded systems, our team can help bring your idea to life. Make sure to check the description below for detailed information about the projects we handle and how we can support you. If this video was useful for you, please give me a thumbs up. That would be awesome. Please don't forget to subscribe this channel and share this video to who likes learn about electronics and learning about the technology and everything in this field. So to the next video, please take care, see you soon, and bye-bye.